So in this case, we are going to have a typical revision. We managed to go through the previous provinces. So like I said, we are going to have a continuation, guys, having as many as we can, trying to figure out how these questions are being given. So this is our KZN province that we are given. That was their common test for the June 2024. So I want to see, guys, as we can see, a similar approach from the previous one that we had for the Gauteng 50 marks, the 1 hour. But let us see how the questions were being given. Like I said, make sure that you go through the instructions and information that you are given. Make sure that you go through, especially here, the degree of accuracy to 2 decimal places wherever it is applicable, unless stated otherwise. On question number 1, quickly going through our questions, we were given to simplify fully, simplify completely, just like factorize fully, factorize completely. But here, it is not about factorization. It is about the simplification. The simplification is supposed to be done fully up to the last stage. All right, so the first part, 1.11, we are given, these are 2 brackets, guys. What do we understand when we are given brackets? This is just an expansion that we need. Remove the brackets, expand the brackets. 3x minus 2 into 2x squared minus 4x plus 1. So by distributing, what we are going to do is to work from the first bracket. The 3x as it is going to expand the second bracket. Then the minus 2 as it is going to expand also the second bracket. That is the idea that you work with, all right? So meaning to say here, if we are to expand, that is 3x multiplies everything. 3x times 2x squared, 3 and 2, the 6, x to the exponent of 3, the x and the x is going to give us to the exponent of 3, x times x squared. Then the 3x multiplies the negative 4x. 3 times negative 4, that's negative 12. X squared, x and x is going to give us x squared. 3x and 1, that's positive 3x. We are done with the positive 3x. With the same idea that we just had, the minus 2 will multiply everything in the second bracket. So that's negative 2 times the 2x squared. So that's negative 2 and 2 is going to be negative 4, but there is x squared. Negative 2 is going to multiply negative 4x. So negative, negative, that's a positive. 2 times 4, that's 8. So it's going to be positive 8x. Negative 2 is going to multiply the positive 1. That's negative 2. And a positive is going to give us a negative like that. All right. Do not forget the like terms. So in this case, we are going to consider the like terms. So that is to the exponent of 3. We do not have any like term for that one. It's just going to remain as it is. Then the part of squared, the squared, the x squared here. So this is negative 12 and this is negative 4. So negative 12, negative 4 is going to give us negative 16. So we've got negative 16x squared. Then we move on to the x. There is x here. There is also x here. So what are the numbers? This is positive 3, and this is positive 8. 3 plus 8, that is what? 11. So that was going to give us 11x. And as we can see, the negative 2 is a constant, and we do not have any like term to that one. We're just going to have our answer as this. We do not have any like terms to be considered there. So make sure, guys, as you are answering the questions, like terms, you are supposed to consider that part of like terms at the end. All right, 1.1, when we are done, we move on to 1.12. On the exponents, that question is about exponents. 4 to the exponent of x times 8 to the exponent of x plus 1, everything over 32 to the exponent of x plus 1. So like I said, guys, you are going to be given similar questions. Understand that. What is it that we can do? There is a product in the numerator, and there is no way, guys, we're dealing with a product of exponents. Let us have the same base. So to which base are we going to have these numbers, the 4 and the 8? To which base? To the base of 2. We understand 4 is same as 2 to the exponent of 2. 2 times 2. But remember, there is x that we have. So that is 2 to the exponent of 2 raised to the exponent of x. Okay? So if you do not understand this, you can use your calculator, guys, in which the number that you're given, you can have it in simplest form. 4 is equal to, all right, on your calculator. Then you're going to have shift. Then you press this button with fact. This one, shift, then you press it. As you can see, it is going to give us the 2 to the exponent of 2, this one. This is the case that we are talking about. It's going to give us 2 to the exponent of 2. So you can have that one on your calculator as well. All right. The same thing, if you do not understand this, same as 8. 8 is equal to, then shift fact 2 to the exponent of 3. As you can see, guys, easy like that. So that's times 2 to the exponent of 3, but being raised to the exponent of x plus 1. Just for the sake of revision, let me just rewrite as it is. Everything over 32. Again, in the base of 2, you can do the same thing. 32 is equal to, and that's shift fact. It's going to give us 2 to the exponent of 5. So that's 2 to the exponent of 5. Everything being raised to the exponent of what? X plus 1. So that is how you were supposed to rewrite the given bases in the same base. We can see that they can be written in the same base. As the numbers are in the same base, it is easier to apply the laws of exponents if it is applicable, or the factorization if it is applicable. I'm saying if. I'm not saying on this question we are going to use factorization. No. But whenever it is applicable. All right, so let us expand. According to the laws of our exponents, we do understand when an exponent is raised to another exponent, you simply multiply the exponents, a to the exponent of mn. So this is it here. Going to multiply 2 and x. So that's 2 to the exponent of 2x times the same. The 3 is going to multiply this exponent. So that's 3 times x. Remember, an expression. We multiply each and every term. 3 times x, which is 3x. 3 times 1, which is a 3. All right. Then everything over the same here. 5 is going to multiply this exponent of x plus 1. So 5 is going to multiply x. That's 2 to the exponent of 5x plus we multiply here 5 and 1. 5 and 1, that's a positive 5. So that's it. We have used this law. And in the numerator, as we can see, we have got a product of the same bases. A is raised to the exponent of m. Another one is raised to the exponent of n. They are of the same bases. A multiplication, we understand that we add the exponents. So you are going to add the exponents. 2 to the exponent of 2x plus you add this expression of 3x plus a 3. So as you can see, these are like terms, guys. So it was going to give us 2 to the exponent of 5x plus 3. This is what you're going to have. So that is 2 to the exponent of 5x plus 3. Everything over what? The denominator as it is 2 to the exponent of 5x plus a 5. This Here, we now have a division. Same base again. It is best for us to have a single base, single term. Not to say there is this one A, there is this another one B. No. Let us have that combined. Which law are we going to use? Remember, a product is opposed by a division. So for a division, we are going to subtract the exponents. All right, the one of the numerator minus the one of the denominator. So here, be careful on your subtraction, guys. Let me just write. It was going to be 2 to the exponent of the numerator, which is 5x plus 3. We subtract. What are we subtracting? This exponent in the denominator. So for a subtraction, guys, it is very, very important that you do open the bracket. Addition, it does not affect, guys. If it is 5x plus 3, then you are adding x plus 3, just combine like that. But subtraction, open the bracket because the negative affects everything. Everything is affected by the negative exponent that we are seeing there. I mean, by the negative that we are having. So that was going to be 5x plus 3. Then negative affects the 5. It will be negative 5x. The negative affects this 5 on its own. It will be negative 5. So that's negative on 5x, negative 5x, negative on 5, negative 5. From there, we can collect the like terms as we can see the part of x here, 5x minus 5x, that's a 0. So these two, we're simply going to cancel. 3 minus 5, that's a negative 2. So that's 2 to the exponent of negative 2. It was supposed to be 2 to the exponent of 0 minus 2. Guys, 0 minus 2 is what? Minus 2. Remember, from our laws of exponents, we are using the laws here. X to the exponent of negative a is same as 1 over x to the exponent of a. 1 over to get rid of a negative exponent. So that's 1 over 2 to the exponent of 2. We just get rid of the negative. So that's 2 to the exponent of what? Of 2 in the denominator. Meaning to say this is 1 over 2 to the exponent of 2, which is 4. That is 2 times 2 is going to give us a 4. So this is how we can have our exponents done on the simplification as the laws of exponents are to be applied or are to be used. The laws, you have a law, you follow that. A law, it is something that you have to follow, guys. You follow the concept. That is how you answer these questions. So the factorization was not even necessary on this question. All right, 1.13. How are we supposed to simplify on this question? We can have this question with an equal sign here. They can just put an equal sign here. It means they want you to solve when there is an equal sign. Wherever they can have an equal sign, anyway, it can be in between, it can be here, they can have an equal sign. When there is an equal sign, you solve. But if we check along our expressions, these fractions that we are given, there is no equal sign. Just combine those fractions by addition and subtraction. As we do understand addition and subtraction of algebraic fractions, make sure that the denominators are fully factorized. All right, so that is it. So here, the numerator is just going to remain as it is, x plus 7 over what? The denominator, let it be factorized, a quadratic there. So you're going to have 2 brackets. Remember, this concept, guys, x squared minus x minus 6. I said when it is a 1 like this, you're going to have 2 brackets where we have got x and x. Remember, x times x, that's x squared. Then you focus on what? Negative 6, which is our constant. We want factors or products of negative 6, 2 of them. But these products must give us a -1 if we combine them. If we add them, they must give us what? A -1. So let's start with the products of -6, -6 and 1, 6 and -1, 3 and -2, -3 and 2. So many factors that we have, so many products. But out of these products, which one, when we add, we must have a -1? The one on the middle term, the one that we see on the middle there. Which one? It is on -3 and 2. If we add these two, you are going to get a -1. -3 plus a 2. That's a -1. But if we multiply -3 times a 2, we must get what? A -6. That's the concept. So these are the numbers, -3 and what? And 2. -3 plus a 2. We are done. All right. So we move on to the other part. As we can see, the x minus 3 is already in simplest form. There's nothing that we are going to factorize or factor out. So that's 3 over x minus 3 as it is. Here there is the 2. It was supposed to be like this, plus 2 over what? 2x plus 2. 2 is common here, 2. Between these two terms, the highest common factor is 2. So I can factor out the 2. 2x divided by 2, that will be what? That will be x. 4 divided by 2, that's a 2. So this is what you were supposed to have. You were supposed to have this condition where it is written as 2 over what? 2 into x plus 2. But guys, can we write that 2 over 2 into x plus 2 here? What is happening between the 2 and the 2? We can see that they are common. It is common, that 2. It's a product, remember. So you can cancel this. You have what? A 1. So you can have that in simplest form if you can see that. So that was going to be x plus 2. So that it does not compromise our LCD or our LCM. With this, we are not going to have anything complicated. Our LCD, remember, for addition and subtraction, you maintain, you keep the LCD. You keep it. You do not multiply by it. You keep it throughout up to the last stage of your question. All right, so let us find the LCM. X minus 3. X minus 3 is common. We need the LCM here or the LCD. So x minus 3, as we can see, it's common. We're just going to rewrite as it is x minus 3. The same, x plus 2 and x plus 2. We're just going to write that one once. So that's x plus 2. This is it. So this is our addition and subtraction, guys. Let us combine this. How do we combine? We are going to divide. But this division, you do it in a way like you are visualizing. You visualize that division. This divided to the denominator that you are given. So as you can see, it was going to cancel, guys. X minus 3 into x plus 2. I mean, x minus 3 to x plus divided to this one. On this fraction, as you can see, they are the same. X minus 3 into what? Into x plus 2. They are the same. They were simply going to what? To cancel. They are the same. They were simply going to cancel. You have what? A 1. So it was going to give us a 1. This LCD to the what? To the denominator. They are the same. So it was going to give us a 1 times whatever that we get after dividing, which is this one. You multiply it to the numerator. What is it that we have on the numerator there? On the numerator, we have got x plus 7. So this is it on our numerator. Minus, we have got a negative there. We do the same thing, our LCM to the denominator. In this case, our denominator is what? X minus 3. We just have one denominator there, which is what? Which is x minus 3. What was going to happen? X minus 3 and x minus 3 was going to cancel. You were going to remain with what? With x plus 2. So it is the minus 3, the numerator that we have, times x plus 2. Since it's a bracket, guys, let us end with the bracket. But we're supposed to have minus x plus 2, which is our bracket, times what? Times 3. Guys, this presentation is the same as writing as minus 3 into this, right? Just one and the same. So instead, we can have it that way. All right, so this is it. We do the same thing, our LCM to this one. So as you can see, x plus 2 and x plus 2 is going to cancel. It is like this, x minus 3, our LCM, x plus 2, into what? Over what? Over x plus 2. This was going to cancel. You remain with what? X minus 1. But remember, the numerator, there is a 1 there. So it's plus 1 into what is remaining? X minus 3. Just like that, because these two, they canceled. But you do not cancel your denominator, your LCD or your LCM. You do not cancel that one. You just assume as if you are canceling, but you do not cancel it. It remains as it is up to the final answer, unless if there is anything common in terms of the brackets, that's where you can cancel. All right, so let's see what is going to happen later on. Maybe we can have that consideration where the numerator will cancel. Okay, expand the brackets, distribute the first bracket of x plus 7. We're going to multiply it by 1. There's a bracket of x plus 2, multiply by negative 3. There's a bracket of x minus 3, multiply it by what? By positive 1. So that's it. 1 times x, that's x. 1 times 7, which is 7. Minus 3 times x, that's minus 3x. Minus 3 multiplies the 2, which is minus 6. We are done with this one. We move on to positive 1. Positive 1 times x, that's positive x. Positive 1 times negative 3, that's a negative 3. Everything over what? Our denominator. X minus 3 into x plus 2, like this. So this is it. We look for the like terms, just like the previous case I talked about this, guys. We're going to need the like terms. So which part are we going to consider? Let us consider the part of x, where we have got our x. There is x here. This is 1x minus 3x plus x. All right. So as we can see, it is going to be like this. This is 1 and this is 1. 1 plus 1, that's 2. And 2 minus 3, that will be minus 1. So that's minus 1x, which is minus x. Minus 1x is same as what? Minus x. All right. We do the same on this part where we are seeing the numbers. That is 7 minus 6, which is 1. 1 minus 3, which is minus 2. So you're going to get minus 2, or you can just use your calculator at once. Remember I said minus 7, sorry, that's 7, not minus 7, but 7 minus 6 minus 3. So that's a negative 2. So that's it. This is what we have. And the denominator, as it is our LCD, the one that we had before, x minus 3 into x plus 2. Remember, I said you do not cancel unless we have something common between the numerator and the denominator. There is nothing to be canceled so far. But if we look closely into the numerator, we can see that a negative there is common. Why not factor it out? So we're going to factor out the negative, so that negative x divided to a negative, it will give us positive x. Negative 2 to a negative, it will give us a positive 2. By factoring out this, that is where we cannot, or where we can tell that the two brackets are the same. That is where we can see it. This bracket of x plus 2, this bracket of x plus 2, they're the same. So these can cancel now. So what are we going to remain with if we cancel? That's a 1. So meaning to say we are talking about negative 1. So it was going to be negative 1 over what? The bracket, this one of x minus 3 is not affected. It remains as it is. It is not going to change to be x plus 3. No, that one, it will be a mistake. You won't change the sign there. It remains as x minus 3 as it was before. So that is how we can attempt these typical questions. You just need to work out as many questions as you can in your revisions. All right. So that was it, guys. As you can see, it's not that much. It's not that much. Just go through your factorization as an individual. Make sure that you understand your factorization. As you can see, they are having a part where factorization is to be considered on its own on 1.2. Factorize fully. So 1.21, we are given 5x squared minus 2x minus 3. So I have explained different ways of this factorization, guys. What is important is that we are supposed to have same answers at the end. But how can we answer this type of a question? I said, okay, let us use the cheat method. Using the cheat method, we said we can try to cheat out this factorization in a basic way that we understand. Which is the basic way that we understand? The basic way that we understand is this one, when the coefficient of x squared is 1, where we can simply have our two brackets like this as usual, so that we do not struggle to factorize such type. So how can we make that one to be a 1 here, while there is a 5? We remove that 5 and multiply it to the last term. So that is what we're going to do here. So as we remove it, this 5, it is going to be x squared now. The 5 is multiplied the last term. So here it will be minus 2x. 5 times negative 3, you multiply by that 5. That is negative 15. So as we can see, the coefficient of x squared is now a 1. It is easier for us to make a factorization for this type because we know this will be x and this will also be x. X times x, x squared. So we focus on the constant, guys. As I said before, the constant is negative 15. What are the products or the factors of what? Negative 15. But these two products must give us what? A negative 2, this one. So minus 15, the numbers will be what? Minus 3 and 5, minus 5 and 3. So if we check this part here, when we add, that's where we get a negative 2 on minus 5 and what? On minus 5 and 3. So we put minus 5 and our 3 here. But remember, we did this factorization from a wrong question because we cheated the part that it was supposed to be. So what do we do now at the end? We bring back that 5 that we lost here. Remember, we multiplied it here. So we have to bring it back where x is. You put the 5. Where x is, you put back the 5 that you had. So in place of that x, let us put back our 5. So that was going to be 5 in place of x, 5 in place of x, this one. So you put it back in place of x. Then you factor out if there is anything common in these brackets, you factor it out. The 5 is common in the first bracket. So we are going to factor out that 5. What are we going to remain with? 5x divided by 5, that's x, minus 5 and 5, minus 1. So that's a minus 1. And this bracket is going to remain as it is, 5x plus 3. As we can see, the 5, it is the one that we're playing around. We take it there, we do this. The factorization, whatever part that you factor out, it becomes useless, this one, the 5. So these brackets are the ones that are representing our answer. So meaning to say, that is what we're going to have. We're going to have these two brackets here, x minus 1 into 5x plus 3. That's why when you see, guys, even if you're checking your memo, They will just give you an answer there. There are so many ways of factorizing, so many ways. Either way, you must have the same answers. So I want you to try using any way that you understand. If we have got same answers, we are on the right direction. But if we are not having same answers, please revisit your factorization concept again. All right, 1.22, we are given again to factorize. Factorize. What are we factorizing here? Sum of two cubes. Remember, if we are dealing with sum of two cubes, we talked about this as a class. If we are given x to the exponent of 3 plus y to the exponent of 3, it is going to give us two brackets, x plus y, which is first plus last, into x squared minus xy plus y squared. Remember the concept of our factorization if we are given this type of a sum of two cubes. So the concept is we have the first term and the last one. So how can we obtain that? A term raised to the exponent of 3 plus another one. Here we can properly see it. We can properly see that one. It is raised to the exponent of 3. But what about this 1/25? How can we know that number? Since it is to the exponent of 3, just find the cube root of 1/125 so that you can simply know which number was it that was raised to the exponent of what? Of a 3. So it was 1/5. So meaning to say, this part that we are seeing here can be written as 1/5 to the exponent of 3. So this is what we want. Just to properly see which one is representing our first term, which is x. So that is our x here. Which one is representing the last term, which is y? That is what? The 1/5. Knowing this, guys, we can use the formula now that we are having here to say this factorization that we are seeing, it is going to give us x plus y. X, that's the first, plus the last. That is what we are seeing. First plus the last. Our first term plus the last term. That is what it means. So that's x plus the last term, 1/5. That is what it means. In place of y, we have got what? 1/5. All right. So that's the first bracket that we are seeing. Into this bracket, so you're going to have a bracket of what? X squared. X represents what? The first term. So it's the first term, this one of x. So as you can see, guys, it's already x. So it was just going to be x squared. Minus xy. What does that part mean? Minus x. Our first term. Our first term here, it's what? It's x. Times the y that we are seeing is the last term. What is our last term? Our last term is 1/5. So if I was going to multiply negative times x times 1/5, it was going to give us negative 1/5x. That's negative 1/5x. Then we move on to the last one, plus the last term squared, y squared. That the last term, our y is what? 1/5. This is our y. So we need 1/5 squared, which is 1/25. You can also use your calculator. 1/5 like this in bracket, then we square it. That's 1/25. So this is what you're going to have, plus 1/25. So this is 1/25 here. You have fully factorized using this concept of the sum of two cubes. You can use that. So as we can see, this is totally, or it is fully factorized. So this is x squared minus 1/5x plus 1 over 25. Just like that. So as we can see, guys, it'll be easier like that, just like that. Let us move on to another question. Question number 2, solve for x. So as you can see, guys, the first equation is basic, but not that basic, because some of us, we are tempted there to solve this in a wrong way. Whenever you've got these brackets, expand, then see the type of equation that you're going to have. So you've got brackets there, 2.11, x into x minus 1 is equal to 6. So let us expand the brackets first by this x times x, that's x squared, x times minus x, that's minus x, which is equal to 6. What type of an equation? We can now see the type of an equation. It is raised to the exponent of 2 quadratic equation. Remember, I talked about the format. Ax squared plus bx plus c must be equal to 0. One of the sides must be equal to 0. So we can take the 6 to the other side so that we've got a 0 there. So that's x squared minus x, the 6 to the other side. The moment it jumps the equal sign, it will be a negative. That's it. A quadratic. Factorize. By factorization, guys, the coefficient of x squared there is 1. So you can simply have 2 brackets knowing that this will be x and this will be x. So that is the concept. You have to factorize this one. So what are the factors or the products of -6, which will add up to a -1? So -6, there are so many. We talked about these guys before. We saw that it was 3 and what? 3 and 2. So that's it. -3 and 2, I mean. So that's -3 plus 2. Remember, I talked about this. It was from another question paper that we had for the June revisions. Also, this concept, we are back again. Product of 2 terms, product of 2 brackets, but the product is equal to 0. I said one of these 2 must be equal to 0. So it is either x minus 3 is equal to 0 or x plus 2 is equal to 0. So we are done. We can have our x there. Minus 3 to the other side was going to be a positive 0 plus 3. All right. Or our x is equal to 2 to the other side was going to be a negative 0 minus 2, which is minus 2. So these are the possible values of x. We are going to have 2 values of x from what we are given. Moving on to another part, as we can see, not wasting time, that's an exponential equation that we have there. So we have got an exponential equation, 2.12, 3 to the exponent of x plus 3 to the exponent of x minus 1 is equal to 36. Guys, here we have talked about this type of equation. We're not going to waste much time here. We're going to separate as 3 to the exponent of x times 3 to the exponent of -1. Now remember, from the factorization concept, since there are 2 terms that are common, 3 to the exponent of x, since there's a term here which is common, 3 to the exponent of x, and this one, we can factor it out. But remember, I said, when a number is not given on this one, it is same like there's a 1. So the moment you factor out 3 to the exponent of x, you are going to remain with what? A 1. So that's 1 plus, on this one, you're going to remain with 3 to the exponent of -1. Remember, you took this one out. So you remain with what? 3 to the exponent of -1, which is equal to 36. Our major question is to solve the equation. It is not about knowing how to evaluate fractions or that, or this and that. So guys, do not waste your time. Use your calculator when you have got something like this. They are not testing about fractions here. So 1 plus 3. All right, this is 1 plus 3 to the exponent of -1 like this. So it was going to give us 4 over 3. All right. So just write this one. 4 over 3 is equal to 36. Remember, this is a product. So how can we get rid of the 4 over 3? We can simply divide by that 4 over 3 both sides. So divide by that 4 over 3, divide by that 4 over 3, so that this can cancel, and you have, or you remain with what? 3 to the exponent of x equal to 36 divided to this one. Like I said, this is not a test for fractions. It's a test on solving equations. So simply use your calculator. 36 divided to the answer that I got before. It's going to give us what? A 27. So this is it. We have a single number there that can be used back to the base of 3, as we do understand that if the bases are the same, the exponents will be the same. So 27 in the base of 3, that's 3 to the exponent of 3. Or like I said, you can use your calculator. 27 is equal to, then shift, you go to the fact. So that's 3 to the exponent of 3, as we can see here. All right, so that's it on this part, meaning to say we're going to have 3 to the exponent of what? Of 3. Which is going to give us now the power to equate the exponents, since the bases are the same. The 3 and the 3 here. It gives us the power to equate the exponents. Remember, we say exponents automatically will be the same. So therefore, x is equal to 3. So this is what you're going to have, just like that. X is equal to 3. So equations, guys, equations. When an equation is given, it can be anyone, all right? So when solving for x, it can be equations, or it can be inequality, like as we can see, 2.13. It's no longer an equation, but we are solving for what? For x. Inequalities, you solve, you do not simplify, you solve. So 2.13, we are given minus 2. All right, so you can just start about this one. X over 3 minus 1 is greater than minus 2. All right, this part of x over 3 minus 1 is greater than 2, but less than or equal to 1. All right, how do we solve? Remember, I said we can solve this one directly by just looking into the question. If you understand this, there's no need for you to separate your inequalities. So we take the minus 1 to this side and also to this side. Remember, there are two inequalities here. So you're solving simultaneously at the same time for those two inequality signs that we are given. So you work with this one, you work with this one. So the minus 1 crosses here, crosses here. Once it crosses, it changes the sign. So it's going to be plus 1 here, plus 1 here. All right, so let's simplify and see. Minus 2 plus 1, that's minus 1. All right, the sign remains as it is. X over 3 is less than or equal to 1 plus 1, that's a 2. How do we get rid of this 3 in the denominator? If you are given a denominator like that, to get rid of the 3, you must multiply by it so that it cancels. You remain with what? With x. But remember, it's an inequality. Whatever that we do here must be done throughout. So meaning to say this side, we're going to multiply by 3. This side, we're going to multiply by a 3. We are multiplying by a positive number, so it does not affect anything. It does not affect anything, this one. So it is going to be x is greater than minus 1 times 3, that is minus 3, is less than or equal to 2 times 3, which is 6. Nothing is affected there. But let's say you were using a negative here. It was going to reverse our inequalities. Remember, a negative for multiplication or division, it reverses your inequality. But this one, it does not affect. A positive does not affect anything. So that was it, guys, on how to solve that inequality. Then 2.2, we are given a condition that a shop sells bicycles and tricycles. In total, there are 7 cycles, meaning to say the cycles include both bicycles and tricycles at the same time. And they have 19 wheels. Determine how many of each are there. Each, which one? The bicycles and tricycles, how many are they? If a bicycle has got 2 wheels, a tricycle is what? 3 wheels. We have equations to be formed from that word problem, from this statement that we are given. We are to form equations depending with how many. All right. So let's start with the 2 things that are measuring our question. And this is the one that we need to find at the end. How many of each are there? Talking of the bicycles and tricycles. So let us just introduce letters for these 2. Let X be the number of what? The number of bicycles, all right? And Y be the number of tricycles, this one. Let us put that way. So X is going to go with what? Bicycles. The Y is going to go with what? The tricycles. All right. But we are told that a bicycle has 2 wheels here. 2 wheels. So remember, we have got 2 wheels. And a tricycle has got 3 wheels. This is what we are given. No problem. Let us form the first equation. The first equation is supposed to come from this statement of the total number of cycles. If we talk of the cycles, we talk of what we have. The number of bicycles that we have and the number of tricycles that we have combined together. There are 7 of them. Those are the cycles. So how do we form an equation, guys? We are saying bicycles represented by what? By X plus in total. How many tricycles? They are represented by what? By Y. So X plus Y is equal to the total number of cycles. There are 7 cycles. You have formed an equation from that statement. You have formed an equation from the total number of cycles. Okay? Let's move on to another equation. How are we going to form another equation? We are going to form another equation from the number of wheels. Because we are told that both the cycles combined together, the bicycles and the tricycles combined together, their wheels, they add up to 19. There are 19 wheels in total. But now if we just say X plus Y is equal to 19, we'll be wrong. It's no longer like that. Because when we talk of the wheels, guys, we are saying a bicycle, it has 2 wheels, remember. A bicycle, as it is one like this, as a bicycle represented by X, but each of the bicycles that we have, it will be having 2 wheels. Each. So for a number of bicycles that we do not know, how are we going to find the number of wheels? We simply have to multiply by 2 on X. So it's going to be 2X. Number of bicycles times the wheels which are found on each bicycle. Plus, we go to the tricycle now. All right? So let us go to the tricycle. The tricycle is represented by Y. But each tricycle has 3 wheels. Each It's got 3 wheels. So it means that's 3y there. 3 times y. The number of wheels times, the number of tricycles times what? The wheels which are on each tricycle. This is equal to what? The total number of wheels that we are given. We are told that the total number of wheels is what? Is 19. That's an equation, guys, that we can see there. Formed from where? The total number of wheels. So that's it. The first one, it was made from the cycles. The second one, it was made from the number of wheels, the total number of wheels. But either part, we have X and Y, and X represent number of bicycles, Y, number of tricycles. So by solving for X and Y, we are finding the number of bicycles and tricycles that we are having. So how do we solve? Using any method, elimination, substitution, it's in your hands. As for me, I'm just going to use substitution from equation 1. So I'm going to use the substitution method. So from equation 1, I can make y the subject. I can make x the subject. It's up to me. So I can just make x, take y to the other side. X is equal to 7 minus y. So that is going to be my equation 3. So you can even make y the subject, whatever that you want. But this equation 3 that we just formed, we are supposed to substitute that equation 3 into equation 2. Remember, we made the subject, this one from equation 1. So you substitute into the other one, which is we're going to substitute into equation 2. All right. In place of x, wherever we see x in equation 2, we're going to substitute with 7 minus y. All right. So let's do so, guys. In equation 2, this is 2x. So that's 2 into our x, 7 minus y. 7 minus y like this, plus the 3y is not affected. We do not have x there. Plus 3y is equal to 19. We have formed an equation with y only, a linear equation. Just expand your brackets, solve for y. All right, as you can see, there's a bracket here. So distribute by what? By 2. Each and every term multiply by 2. 2 times 7, which is 14. 2 times negative y, that's negative 2 y there, plus 3y is equal to 19. All right, let us collect our like terms. As we can see, there is y and y on the left-hand side here. So these two can be combined together, meaning to say it was going to be 14 minus 2 plus 3. That's 1. So that's 1 y like this, which is same as y is equal to 19 on the right-hand side. So how do we solve for y? We can simply transpose the 14 to the other side so that it will be a negative the moment it crosses the equal sign. So y is equal to 19 minus 14, which is what? Which is a 5. Just like that. So this is how we are going to calculate the part of y, meaning to say y representing the number of what? The number of tricycles. So meaning to say we have got 5 tricycles, all right? Anyways, guys, let us just solve for x. X from equation 3, remember we made equation, we made this one the subject and had equation 3. It is already x, the subject there. So you can simply use this part, guys. X is equal to 7 minus y. What is the value of y? Y gave us a 5. So x is equal to 7 minus 5, which is 2. So x is equal to 2, meaning to say we have got 2 bicycles in that case. Remember, this one is representing here the number of bicycles on what? On x. So that is the condition. So that is what we have here. 2 bicycles. And on the part of y here, when we solved for y here, we calculated for the what? For the tricycles here. So we've got 5 tricycles. So that was the question. So you see, guys, it is not always where you shall be given direct simultaneous equations. Sometimes they want you to be the one who is formulating, to be the one. Question number 3, we are given f of x, which is given by the equation. All right, so this was supposed to be x. That is x minus 2. And the g of x is given by the equation 3 over x. 3 over x. So this is what we're given, which are not drawn to scale. So don't measure anything because we don't have a scale there. But we are given that A and B are the points of intersection of the two graphs, all right? DF, this part here is perpendicular to the x-axis. As we can see, there's a 90 that we have there, with points E and F on the graph of G and F respectively. So they're saying here with points E and F. So E and F, the point E is on this graph of what? Of G. G and F, this one. G and what? And on F. That is where we have got these 2 points, E and F. All right, no problem. So with this information that we have, we are going to use it to answer our questions, which was to 3.11 to determine the coordinates of the point C. The coordinates of the point C. Where is C? C is the y-intercept. As we can see, it lies on the y-axis. It is the y-intercept of what? Of F, this one, our straight line. So we know that guys, the y-intercept is on a condition where x is equal to 0. So we're just going to substitute as 0 there. Y is equal to 0 minus 2. So y is equal to minus 2. So at C, the value of y there is minus 2. But remember, I said x is equal to 0. So therefore, the point C can be given as 0 minus 2. As a point, the question needs us to have this one as a point. So that's 0 minus 2. 3.12, the coordinates of A and B. A and B, where do we have A and B? Remember, A and B are those points of intersection. At the point of intersection, we do understand that the two graphs are equal, or the two graphs will be equal. That is the idea there. So to find A and B, we simply work with what? Point of intersection. So meaning to say f of x must be equal to gx at the point of intersection. These two graphs will be equal at that point. What is our f of x? X minus 2 is equal to what is our gx? 3 over x. What have you formed? An equation. From this consideration, guys, we have formed an equation which we are supposed to use to solve for x. To find the point of intersection, as you can see, there is A here on this side. We're going to have an x on the negative. B, we're going to have x on the positive side. So definitely, there are two possible values of x. So we are going to have a quadratic. By just knowing this, we must have a quadratic. How are we going to have it? Cross multiply, because this is the same as over 1. So if we cross multiply, that's x times x, which is x squared, x times negative 2, which is negative 2x. And that is equal to 1 times 3, which is 3. Remember a quadratic equation, when the highest exponent is 2, one of the sides must be equal to 0. So we're going to transpose this to the other side. So that was going to be x squared minus 2x. 3 to this side was going to give us a negative 3. All right, that is equal to 0. Then you can even apply your factorization here. So factorize, guys, as we saw before, this type of an equation. You're going to have 2 brackets. That is x here. Factors of negative 3, which gives us a negative 2. Factors or products, that's negative 3 and 1. 3 and negative 1. But where we get a negative 2, where is it that we have a negative 2? It is between -3 and 1. That's where we get a -2. So that was going to be -3, +1. Remember, one of these brackets must be equal to 0. We talked about the zero product, guys, from other questions. So we take one of these brackets to be equal to 0. So therefore, x is equal to -3, crosses the equal sign. It was going to be positive. 1 crosses the equal sign. It was going to be a negative there. So these are the values of x at the point of these points of intersection. The one is +3, another one is -1. Which one is +3? Which one is -1? -1, guys, as we can see, that's on the negative side here. So the -1 is for the point A. -1 is for the point A, and the 3 is the one for the point B. But remember, we want exactly the point. So having these values of x that we are seeing here, we are going to substitute to find the y values. Where do we get the y values? In any one of these two equations. Remember, I said at the point of intersection, f of x is equal to gx. So you can use anyone. So as for me, I'm going to take the first one from f of x. All right, from f of x, y is equal to x minus 2. From what? From f of x. So let us start. We said when x is what? Remember, we got two values here. When x is equal to 3, we substitute that y is equal to, in place of x, that's 3 minus 2 in place of x. So y is equal to 3 minus 2, which is 1. So it is a point now where x is what? Is 3, the one that we substituted. Y is 1. It's a point. You do the same thing in this consideration. Remember, another x that we got was -1. So you substitute when x is -1 in place of x, -1, -2. So y is what? -3. It's a point, this one. When x is -1, y is -3. It's a point. -1, -3. It's a point. Not to say you write those values with a 0. No, these are not x-intercept. They are not found in the x-axis. No. These are points which lies on the function. That is the graph that you're given here. So you must properly substitute. Not to say this one is 3, 0, this one is -1, 0. No, that is wrong. So like I was saying, which one is suitable for A? Which one is suitable for B? A is on the negative side. So definitely this is our A with a negative value of x. All right. B is on the positive side. So this will be our point B. So that is it from that consideration. Just like that. It was just like that, guys. All right. Then another part, it was 3.13. The length of EF. All right. We need to calculate the length of EF from our diagram, but we still have that statement. All right. Let us just see what is happening here. The length of EF, which is this part, is the one that we need to work on. The length of EF, this part here. This is the part that we want. But they are saying if, it's a statement that you must consider. If OD is equal to 6 units from O to D. If from point O to point D like this, it is 6 units. So if it is 6 units, it simply means at point D here, the value of x is 6. At point, the distance from the origin to D, it is 6 units. So it simply means at that point D, x is equal to 6 at point D. And remember, this is a perpendicular concept where these two lines are perpendicular. So when it is like that, this broken line that we are seeing here, it is a vertical line, as we can see, where the x value is the same throughout. Throughout this line, x is the same. So how can we now determine the length of what? the length of EF. We just have to find the Y value at F and the Y value at E. That is the condition. That is the condition. So find Y values. Find the Y value. The Y value at what? At F and at E. How do we find the Y value? Because we've got the X value. Because this is a vertical line. X is the same throughout. It means, guys, this is a vertical line. A vertical line, it means the values throughout, they are the same. At E here, at point E, that we see, X is equal to 6 there. At F here, X is equal to, as long we are on this line, X is equal to 6. So we can take advantage of that. F lies where? F lies on this straight line. F, the point F lies on F of X, which is our straight line. All right? That is what is happening here. So F is found on what? On F of X. Remember, that's Y is equal to X minus 2. We need the Y value, knowing that our X is what? Our X is 6. Knowing that our X is 6. So Y is equal to, in place of X, you substitute as 6. So that's 6 minus 2, which is 4. So this is the Y value at F there. It is corresponding to F4. That is the Y value that we are seeing. Okay? We are talking about vertical, so we talk of the Y values. We do the same thing at E. All right? So at E, what is the Y value? At E, E is found where? Look where look at this function here. This one. This is where E is found. And this is the same function as this one, which is found on what? On G. So E lies or is found on what? On G. So on G, Y is equal to what? G of X. Y is equal to 3 over X. So if it is 3 over X, what is the value of Y there? The only thing that does not change, guys, is the value of X. X is not changing. Remember, I talked about this throughout. At E, X is 6. So you're going to substitute as 6. 3 over, in place of X, you substitute as 6. Remember, 3 over 6 is 1 over 2, which is same as what? 0,5. So this is the Y value at E. So the difference between these two is the length. The length, if you are talking about a vertical line, you subtract the Y values. If this is Y2, this is Y1. The length will be Y2 minus Y1. So this is the consideration. At F, we're just going to call Y2. At E, Y1. So it was supposed to be Y2 minus Y1, meaning to say we are simply talking about the Y value at F minus the Y value at what? At E. What is the Y value at F? We calculated that one. It is 4. Minus the Y value at E, which is on the bottom, which is 0,5. 3,5 at the end. This is the length. So that's 3,5 units. Just going to write as what? As units. So this is the length, guys. If you're given a vertical line, you work with the Y values. If it was length, but it's on a horizontal line, you work with X values. So the length will be the difference of the X values, X2 minus X1. Vertically, Y2 minus Y1. If you understand that one, guys, you are done. That is how you answer this type of a question. So our length was going to be 3.5 units. All right, another question, 3.14. The equation of J, if Jx is equal to Gx plus 2. All right, so there we are already given how it is supposed to be written as. There it is just substitute and write the final answer in simple. That is what they are trying to say, guys. You are given a straightforward question. They are saying there is an equation that we are supposed to have for Gx. But it is supposed to be written in this form for jx as gx plus 2. We already have this one, guys. It's already there, the gx. It's already there. So if it is already there, simply substitute it. Simply replace it with its equivalent, this one, because it's already there. So what is it from the information that we are given? What is our gx? Our gx is given here as what? 3 over x. So you substitute as it is 3 over x plus what? Plus 2. This is what they want you to just have it. Just like that. So if they said maybe it's f of x plus 2, how are you going to write it? It was going to be given as gx is equal to, in place of f of x, you take your f of x as it is, x minus 2. But what are you supposed to do at the end? You must add a 2. So it was going to give you x minus 2 plus 2, that's a 0. So it means your jx was going to be what? Was going to be x. I'm just saying if, let's say, they wanted you to work it from f of x. So that's how you answer this question. You just add whatever that you're given. If it is a minus 2, you subtract that. If it is a whatever that you have there. All right. Another question. They are saying, on this question, we must be very careful. 3.15, the values of x for which f of x is greater than or equal to gx. I talked about this, guys, when a function is bigger than another one. It simply means f of x is above. Where is it that f is above of g? But on that consideration, we are also limited that it must be on a condition where x is what? Less than or equal to 0. We must not exceed this condition on our answer. Yes, we need where f of x is greater than gx, but limited to values which are less than or equal to 0. Meaning to say, values that are less than or equal to 0 in terms or in form of x. We are talking about the x values, guys. These are the x values on the horizontal axis. So this is where we've got our 0 here on the origin. Where is x positive? This side. But they said our x values must be less than or equal to 0, meaning to say we need to work from the left side, from the negative side of our x-axis. We have nothing to do with x, which is greater than, which is this side here, or which is this side, guys. There is nothing that we need from this side. That is what they are trying to say. Don't waste your time looking into the right-hand side of your Cartesian plane here. This one, it's not useful for now. Our answers are only limited from this side, from this y-axis going to the what? To the left, where x is less than or equal to 0. This is the side that they are saying focus on this side, only this side here. Where is it from this side where we see f of x greater than or equal to gx? Where is it that we see our f of x above gx, on top of gx? That is what it means. So if we are to consider this is our f here, our f from here to point A, it is below G, as we can see, this is our G. It is below this one. But as we move from point A to our y-axis, the one that we are at here, we can see that at this point, this small distance that we are seeing here between here, this small distance that is left here, this small distance that I'm indicating, this one. We can see this distance of f. It is above G. Look at G. G is down there. F is on top. G is below. This one, G is below. Whilst F is on what? On top. From this point A up to the what? Up to the y-axis, up to the point where x is equal to, remember we are limited to where x is what? Less than or equal to 0. So at A, what is the value of x at a? At a, our x is -1. So x is supposed to be greater than or equal to -1. Remember, there's an equal to there. But less than, we now use that condition that we are given. Remember, we are limited to a condition where x is what? Less than or equal to 0. So answer the question properly on that one. Just like that. So I don't know, guys, how you understand this question, but it was a limit type of a question where you are limited not to use another part. All right. 3.2, sketch this graph from these from this information that you are given from these points. That's hx is equal to this ax squared. That's a parabola. So we are dealing with a parabola, a quadratic. All right. But on this parabola, we are given that the range is what? From -4 to infinity. Remember, range, we are talking about the y values. The y values, they are limited from -4 up to infinity, meaning to say the graph is going up. So when it is going up, it simply means our graph is supposed to be like this. That is the idea there. It is limited at -4 going up. All right. Another point, a is not equal to 0, but it is such a way that it is greater than 0. If a is here, a, remember, it tells us about the shape. If a is greater than 0, that's a positive value. We are going to have a smiley shape like this. So it simply means, guys, this part, as we are going to have, the shape is going to be like this. We are already having that. Passing at -4, and the q is less than 0. That is what exactly you can see, because it's at what? It's at -4. So 1 root of h is positive and 1 root of h is negative. From our hx, we know, guys, from this type of a function, it will be symmetrical. I talked about this, guys, that it will be symmetrical about the y-axis. So this is the one they are talking about, those roots or solutions, the ones which lie on the x-axis. So there's a solution here and another solution on the other side of the x-axis. But remember, we are told the range -4 up to positive infinite, meaning to say our graph is limited downwards at what? At -4. But it must be having a smiley shape. It must be having a cup shape like this. So that is a sketch that we can have. We do not have full information that we can even name this function. No, we just have this part only. So that is it. So this is -4. These are the solutions, the roots where it crosses the x-axis and being symmetrical about the y-axis. We are done with our sketch. Another question, given this part that we have, write down the equation of the asymptote. I talked about an exponential function, guys, before. This is the part representing our asymptote. So y is equal to -12. That's our equation of the asymptote that we are given. Determine the y-intercept of g. So the y-intercept is on a condition where x is equal to what? Where x is equal to 0. So where x is equal to 0, the value of y is what? We substitute as 0 here in place of x. So that's 3 times 2 to the exponent of 0 minus 12. Knowing that any number, guys, to the exponent of 0 is 1. So that's 3 times 1, which is 3 minus 12. And 3 minus 12, that's a negative what? A -9. So that is the y-intercept of g is -9, or you can write as 0, -9. Determine the x-intercept of g. So the x-intercept, remember, y is supposed to be equal to 0 this time for the x-intercept. All right, so let's see. 3.33. So that's y is equal to 0 this time for the x-intercept. So in place of y, we're going to put a 0 there. So 0 is equal to 3 times 2 to the exponent of x minus 12. Then we solve for x. As we can see, the moment we try to solve this equation, you can see it's an exponential equation. So we must use the laws of exponents wherever they're applicable. All right. The minus 12 is nothing. Let us just take it to the other side so that it can be a positive there. So 12 is equal to, we're going to remain with the product of these two. All right. So let's see. That's 12 is equal to 3 times 2 to the exponent of x. It's a product, so we can get rid of these 3 by what? Dividing by it both sides. So it simply means 12 divided by 3, that's 4, is equal to 2 to the exponent of x. Remember, guys, I talked about this. If the bases are the same, the exponents will be the same. So let's have 4 in the base of 2. 4 in the base of 2, that's 2 to the exponent of 2, which is equal to 2 to the exponent of x. The bases are the same, so automatically our exponents are the same. So x is equal to 2. So that's it. The x-intercept, that's 2. So meaning to say we've got 2, 0 there as our x-intercept. Then finally, sketch the graph of G, clearly showing the asymptote and the intercepts with the axis. All right, so remember we have got our x-intercept, y-intercept. So let's start with the asymptote, guys. Whenever you've got this type of a graph, start with the asymptote. We do not have much space to work with. I'm just gonna like the graph that we can use. So I'm just gonna have a sketch, guys, on a plain part. Let's just hope you will understand me. So these are the x values, the y values. As you can see, our graph, it is more negative on the y values. On the y values, we have got an asymptote at what? Negative 12. Negative 12. So let us just say I've got something like this. That's 0. 0 here, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. All right, then here I'm just going to also use 2, 4, 6, negative 2, negative 4. All right, so we have got a simple thought. It's an equation, this one. Y is equal to minus 12. Let us use a broken line. Y is equal to minus 12 here. So we're going to use a broken line for our asymptote like this. So that's it as our asymptote, this one. Y is equal to minus 12. Remember, that's an exponential function, and we know the shape when it is like this supposed to be something like this, guys. But even if you do not know, just indicate the intercepts and see. The y-intercept is what? Negative 9. Y-intercept, negative 9, definitely negative 9 is in between negative 8 and negative 10. So somewhere there, we have got our negative 9. That's our y-intercept. The x-intercept is at what? At 2. This is our x-intercept at 2. So as we can see, that shape was going to be automatically presented an exponential function as it tends to reach the asymptote. It will be like this. It will be decreasing, tending to be like it's going to meet the asymptote like this, something like this. So that is the condition of our function. No, the shape, guys. If you're dealing with functions as an individual, just have an idea of, I'm dealing with an exponential. The shape is like this. When it is like this, the shape is like this. I'm dealing with a quadratic. The shape is supposed to be like this. Know that one as an individual. It can help you a lot in your revisions. So that was it, guys, for the total revision that we had. Just make sure that you do go through as many question papers as you can for June so that you can have an idea of how they are going to be like as you are working with your annual teaching plan, the ATP. Make sure that you revise using that one to prepare for the tests which are ahead of time. But for now, guys, that is it till we meet again.